Hello. Okay, good morning, good afternoon, good evening, wherever you're located. I hope that we can to start with our webinar. Welcome on our webinar with the name Let's Meet PowerPad, a new solution for power line design. Today on this webinar, we will present you our solution PowerPad, which is for power line design. My name is Petar Dragic, and it's my pleasure to be your host and your moderator, and actually one of the presenters on today's webinar. With me on this webinar are my colleagues, Nenad Blagovic and Stevan Bacevic, who are software and electrical engineer. And today we will present you together this solution for power line design. At the beginning, just a few words about webinar rules. Like you saw on your registration, we use Microsoft Teams webinar for our webinars. And now when webinar start, you see that all of you are mute. It doesn't mean that we don't want to hear you. It is just easier for us to communicate with you through the chat. And please use chat command to write your questions. At the end of the webinar, we will answer on your questions. Of course, we are human beings, and if you want to express your emotions or share your empathy with us, please use command reactions in Teams webinar. Let's go on webinar agenda. Today, I think a lot of you are for first time to meet this solution, and that is the reason why we go so detailed in technical preview. Actually, first we will have a short introduction about the PowerPad workspace. Then we will go on PowerPad features to present you the main features of the PowerPad. Actually, we will create one example of the transmission lines, but this is the process or work process how to design all of the lines with the PowerPad. At the end, we will have a Q&A section. In this part of our webinar, we will answer on your questions. If we wouldn't provide answer today on your question, we will answer later on your email. All of our demonstrations today will be live demonstration, and I need to say that I'm honored to be your first presenter today. And now I will jump directly in PowerPad for a short introduction about the workspace of the PowerPad. Let's go in PowerPad. Okay, this is the solution PowerPad, and at the beginning I want to say it is the standalone solution. It is not just CAD plugin. It is standalone solution with native format DWG. What it means? It means that this solution or the project done with this solution are saved in the DWG file, and of course it can be shared with other colleagues or companies which using any of the CAD or BIM solutions. What is important here, I want to, just in few words, to present this workspace. Like you see on the top, we have different ribbons. First ribbon or first tab of the ribbons is with the name PowerPad, and here on this ribbon are all commands for power line design. On other tabs and the ribbons, you have other functions for 2D drafting or 3D modeling. Okay, let's go back on the tab PowerPad. Like I mentioned, all functions are here on this tab for power line design. Function can be run directly from the ribbon when you click on the function, or if you type in command line. What is also important, we worked hard to prepare a solution which will be really user-friendly and, better to say, easy to start to use. For example, first we create the Common Project Explorer. This is very interesting comment because in this panel is in Project Explorer palette actually you can to see all of the elements of your project. For example, all surfaces, all power lines, profiles, for example, data models, etc. My colleagues will later describe more about all of these comments. What is also important, on the right side, you have also different palettes. For example, the usually used are properties palette, for example, when I click here, and layer palettes. Okay, at the beginning I mentioned the native format of the project done with the PowerPad is DWG. And for example, if when I go to, for example, to save project, you can to save a project in DWG file. Of course, that is important. PowerPad provide option to generate BIM models, and it means that models can be created or saved in IFC file. For that, we use the command export IFC. It is also important that all of the objects which are maybe designed in different solution can be imported in PowerPad. In my example, I have one infrastructure project with roads, bridge, and power line, and all of that can be shown in the PowerPad. When you want to use other commands for 2D drafting, it is easy just to go on Remote Home, and here are other commands for 2D drafting. For example, this is Take Home. When I go further, for example, for View and etc. If you want to use commands which are for 3D modeling or 3D BIM modeling, it is very simple. You need just change your profile. For example, you can click here and change on modeling. Then solution will load commands for 3D or 3D BIM modeling. When you go now on tab Home, here are all commands for 3D modeling. I think it is enough just for this short introduction about the PowerPad workspace. Like I mentioned before, at the beginning, if you have any questions, please type in the chat and then we will answer on that. Let's go further. Now my colleague Nedeljko will continue with presentation and he will present the main PowerPad features on one example. Nedeljko, please, the screen is yours.
Thank you, Petar. Hello, everybody. My name is Nedeljko Blagojevic, and I'm software engineer, and I will show to you how to design power line in PowerPad software, and also I will show to you how to use basics commands in this software. So let's start. First icon from the ribbon panel is Project Explorer. In Project Explorer palette, we can add, remove, and edit surfaces, power lines, and all power lines elements, including supports, insulators, and conductors. And we can add, edit, and remove profiles, data models, weather, and referent conditions. The second panel is a surface panel, where we can add or create, remove, and edit surfaces. Here we have a few options for creating surface. We can create surface from file, from points or polylines, or we can create by placing points from 3D face or from civil 3D face. In this video, I will show to you how to create a surface from points or polylines. I just first want to mention about this image. This image actually includes survey data with points elevation, and now I'm going to create a surface from points or polylines. I just need to use this command. pressing enter, and now my thin surface is created. Thin surface actually means a triangulated irregular network. It's actually surface generated from triangles based on points. I can see on this annotation that my thin surface is created. Also, I can see it when I click here on the properties panel and select the surface. And here there are a lot of additional information about the surface. And also here we have a few options. For example, we can turn on and off boundary lines, points, triangles. For example, I will turn off the triangles. And for example, we can turn on the contours. Now you can see contours. Contours represents points with same elevation, and here we can, to set contours, we can choose a major contours interval. We'll change this to double. This we will change to 5 times more, and now we can see that our configuration of thin contours is changed. Also, we can change here major contours line color and minor contours line color. And a very interesting thing is this section, thin statistics, where we can see a few additional options and additional informations like number of points, number of triangles, minimum elevation, and maximum elevation. Now I'm going to turn off the contours, and I will turn on the contours. Now I will show to you how to assign a raster image. To assign a raster image, you first need to turn on triangles, which we already do, but we also need to turn visual style on realistic, and now we turn it on realistic. And to assign image, we just need to click on this icon from the surface panel and follow the instructions from the command bar. Here is written to select thin surface. I will do it. Now I select, then a new command, select raster image. Okay, and now we can see that our image is assigned. Now I'm going to turn off visual style and came back to realistic. I'm going to select my thin surface and turn on triangles. Turn off triangles, because I want to, in next step, to draw power line, and it will be much more visible to me if I turn off the triangles. Here on this surface panel, we have a few additional icons for edit surface or for name surface, and also we have a very useful icon for import land XML and import civil 3D. On another drawing, I will show to you how to use this option, import land XML. Here on this drawing, we have already created a thin surface, and also we have here created power lines. This is power line 1 and power line 2. We can see that the power lines in Project Explorer, including their supports. Now I'm going just to little rotate for better visibility. And now I am going to import land XML. I just click on this command and find my XML file. In this case, that XML file actually represents a rod, and I just will open it, and you can see it. That's again a thin surface. Now I'm going to rotate just for a better view. Now I'm going to switch to the main project. That's of course my PowerPath example. And in the next step, I will show to you how to actually draw power line, or how to create draw power line. Here we have two options for creating a power line. We can draw power line, or we can import a power line based on power line coordinates. It's actually based on support types and support position. In this case, because I already have created a thin surface, I am going to draw power line. I click here, and in the opening dialog window, I can define here a power line name, a station. This is a support name prefix, and this combo box is actually support counter starting value. Here we can choose a tension support model. I just want to mention to you that we have two types of support models, tension and suspension, and this is weather and referent conditions. About weather and referent conditions we will tell later in much more detail. And of course, very important thing is to check this option, drape on existing surface, if I want to have my 3D representation of power line on the surface. And now I just need to click on draw and start drawing. Now I will draw this power line in direction of the rod. So I will start with first tension support, this is second, third, fourth, and the last one. And I'm clicking on enter. When I zoom it, I can see that we can see here information about support types. This is tension support, and of course about support name. We also can move this power line, or it's actually we can move this tension supports. It's just need to click on the power line, select the vertices and move it, and that's it. Now I'm going just to rotate this view, and now we can see that our 3D model of power line and are created automatically. That's very nice advantage for this software. And when I zoom it, we can see our support. It's actually 3D model, of course. And next step is to add support. I will show to you how to do it. Just click on the icon and just select the power line here. And we can add two types of the support. We can add suspension and the tension support. Now I'm going to add suspension support. I will say this data model, and we just need to pick point where to place suspension support. I will place the suspension support on this point where our rod crossed, and I just click on it, and I'm going to click on OK. Here we can see that our suspension support is added. We can see its mark SS. It's actually mean suspension support. We can also see it in 3D representation of the power line. Next step is to add insulator. First, I will show to you how to add insulator on this suspension support. Just click on the icon, select the support. Now I'm going to select it here, and we need to select the attachment point. I just want to tell you that the attachment point is actually place where insulator is attached to the console of the support. This is support, this is some kind of console, and this is attachment point. Now I need to select that attachment point, and here in the opening dialog window I can choose insulator type. In this case we will stay suspension, and of course insulator data model. For example, we will use this, and of course I will check this option apply to all supports of the same data model, and I'm going to click on OK. Just wait, and now we can see that our insulator, it's actually our 3D model, is automatically added. And this is a step for adding insulators one by one, but actually we can add more insulators just in one step, and I will show to you how to do it. Just need to click on this icon, edit insulator, follow the instructions from the command bar, select support, and here we have options to automatically add more insulators on attachment points just in one step. So I will select, for example, this, for example, this, and for example, this, and now I'm going to check this option, apply to all supports of the same data model, and now I can see that I have added all insulators on my tension supports. Procedure is the same for tension supports. Once again, click on edit insulator icon, select support, and just select insulator's type. That's on this way. just need a little time to select them all because it's 5 insulators, and of course check option apply to all supports of the same data model. And now when I click on OK, just wait a little time, we can see that our insulators are added to all tension supports. Now when we draw power line, when we add supports, actually we add one suspension supports and we add insulators, it's time to add catenaries, or actually it's time to add conductors and ground wires. First, we are going to add conductor. Just need to click on the icon, select the power line, and the opening dialog window we can define conductor name. This is actually predefined name, in this case phase 1. We can change it, of course. Here we can choose conductor model. In this section, we can choose support range and, of course, which attachment point to attach a conductor. And like I said, here we choose weather and referent conditions. I'm just going to click on OK, and you can see it that new conductor is actually added to the power line. Now I'm going to add 2 more conductors. I can repeat last command by clicking on enter, and now I will stay all parameters same for adding second conductor, just change the name to phase 2, and I'm going to click OK. Once again, I'm pressing enter to add third conductor and just change here to phase 3. And now I just want to add ground wire. To add ground wire, select option ground wire, select the power line. Procedure is the same. Opening dialog window is almost the same like for add conductor. Here we will stay ground wire 1, and we will click on OK. And now we can see here 4 catenaries, 1 ground wire, and 3 conductors. Now, next possibility in this software is actually to create power line profile. I just want to explain you what is actually power line profile. Power line profile is actually represents a 2D vertical projection of power line elements, and it includes some data about power line. So let's go to create it. Just click on the icon, select the power line, and here in the opening dialog window on general tab, we can set name. For example, I will stay here profile. Here we choose support range, and this is the list of our conductors and ground wires included in that profile. On preference tab, we can set horizontal scale and the vertical scale, and we use this, of course, for plotting. And I will check this option, show left and right terrain profile. It actually represents terrain elevations and by distance, in this case, 10 meters from power line directions. On the next tab, I'm going to click on the rubrics, and here we can set visibility, name, rubric height, and text style for station, terrain elevation, span, tension section, conductor, and ground wire. And finally, in this last tab, we can set visibility for number, name, model, height, and type. It's actually support annotation, and of course we can set catenary annotation for lowest point marker to show it or the height, and the same thing for maximum sag marker. Now I'm going to click on OK, and just need to select the place where to put my profile. Now I just wait to create it. OK. We will wait a few. OK, now my profile is created. Now I will zoom it to explain you more detail about this. Here we have support name, support type, height, and support counter starting value. Here we can see our catenaries. ground wires and ground wire and conductors. And here we can see our terrain profile. Green line is for terrain profile, and blue is for a right terrain profile. That's offset in profile, and the orange is actually a left terrain profile. Down we have some additional information about station, terrain elevation, span, tangent section, conductor, and ground wire. And we can see data in these rows. And that's all for the profile. This software also has a possibility for adding data models. We can add support data, insulator data, and add conductor data. To add conductor data, we just need to make a few settings in this dialog. Here we can define name of the support. Here we can define type, height, and we can define which 3D model we want to use, system generated 3D model or 3D model which we will import like DVG file. The same thing is for plan symbol, and here we can add, edit, and remove attachment points. I will just show to you how to add attachment points. In the opening dialog window, we can define here attachment point name. We can define a type. We have three types: tangent, central, and ground wire. And of course, we can set attachment points position. Once again, to repeat, attachment point is just a place where insulator is connected for console of the support. Now, edit support data dialog is almost the same, where you just edit your support data. To add insulator data, you just need in this dialog window to set value of name, and you can choose a type of insulator data, and of course set some physical parameters like length, weight, and wind area. And of course you can choose which type of 3D model you want to use, system generated or custom value from DVG file. And the third icon in this panel is actually for conductors. Add conductors data. I will show to you this option. Here we can add a new conductor to our existing conductor database, and here we can define the conductor name, for example, this cross section, for example, this diameter, for example, this specific weight, elastic modulus, temperature coefficient, and finally nominal tangent stress. And now I'm going to click on Add. Now I came back in Project Explorer, choose Data Model section, then Cables, and finally Conductor Model. This is conductor model which we created. I can edit it from here, or I can edit it from here. And that's all for now from me. Later I will talk more about IFC and BIM models. And now my colleague Stevan will tell you more about weather conditions, reference conditions, and creating reports. Thank you once again.
Thank you, colleague Nedeljko. Greetings from me too. My name is Stevan, and I'm software engineer. And I will present you how to add your weather and reference conditions. Before we start, I want to mention that I will use the same surface as my colleague Nedeljko, as you can see. So, if you want to add your weather reference condition, you have to go on these icons in this ribbon panel, and you can add or edit them. If you just press them, you can see two options. Of course, you can add and edit them in Project Explorer. If you go here and click on your right click, you can add them. when you already create them, you can edit them or you can remove them. It also mean for reference conditions. So now I will show you a short example of how to add and create them. Now I will go to add reference conditions. Go here, just press add, and you will see the new opening window. In this opening window, you have name. For example, I will put reference condition 1. Then you have your temperature. You can choose to be based on critical span, or you can choose your custom value. For example, I will choose 10 degrees. And you can choose your tensile stress. It could be nominal tensile stress, or it could be your custom value. For example, I will choose 70 megapascals. You can choose if you want ice to occur in this reference condition. Now just press add. Then, if you want to add your weather, go here on this icon and just press add. You will have the new opening window. You of course already you have your name. You can put, for example, I will set new weather name like weather 1. I will choose new temperature like 50 degrees, and I can choose my isolate if I want my coefficient, and if I want my isolate to occur at this weather condition, and I can choose if I want wind load. By that I mean wind pressure. So you can choose, for example, I will choose 600 Pascal. And I can set if I want what direction I want, if I want the left or right wind direction. So you can just add. I will just use 3D model just to see, okay. And now when you create them, you want to add them to your power line and conductors. If you don't have power line, you want to create a power line, you can go here, as my colleague Nedeljko said, go here, draw power line, and in this box here, you can see your weather and reference condition. If you go here, you can see my example that I created for weather, and of course that is for reference. But I already created my power line, and if you already have your power line, then you have just go here on this icon. It's called Edit Power Line. Then you have to choose your power line, and again here in this dialog you can choose your weather or reference condition. For example, reference 1, and then I'll choose this and just press OK. This also means for conductor. You can just go here on this icon, conductor. If you don't have conductor, you can just go add conductor and choose your edit, or you can just second power line, you can edit here, as you can see, or you can go here. If you already have your conductor, you can just go on this icon. It's called edit conductor, choose your conductor and choose your reference and weather conditions. So this is everything about weather reference conditions. Now, one of the most important things in this software is reports. So we have here 3 types of reports. If you go on this icon, in this view panel, you will see 3 of them. The first one is called sag-tension report, and it's about all data of your conductors. Then you have in that report, you will have, I will show you later, that you have your maximum sag at some temperature, critical span, rolling span, critical temperature, and you will have all your tensions and saves for all temperatures you choose and for all your supports and conductors. In this one, it's called support report. You will have you will have conductors and ground wires, I think about models, and you will have all lots of conductors on attachment points. You will have insulator lots on attachment points, and you will have lots on support. And in this third one, it just coordinates of your supports in your power line and what types of them. So if I go here, create sag-tension report, in this window you can see that you have to select your power line. When you select your power line, you will see the new opening window. Here you can choose from what support you want to create. I can choose from support 1 to support 7. I can create for all phases or just here, or just to choose one. I will choose all, and you can set your temperature range. For example, it could be from -20 degrees to 80 degrees, and you can choose your step. I will choose 5. Here you can save this report as TXT extension or Excel extension. I will show both of them. And here you can check if you want to open it immediately after you save. So if you press OK, you will have a new window. You have just to save that, for example. Okay. Press save, and you will have the new window. Here in the new window, you can see your report. As I said, you have your data for your conductors, like name, type, cross-section, diameter, etc. And then you have your span length, rolling span, critical temperature, and span maximum sag. And as you know, I created temperatures from -20 degrees to 80 degrees with step 5. And for them, you have all stages and tension. Of course, you also have your load calculation if you want, if you have wind load, ice load only, or both of them, or neither. And that's for all your phases, phases 2, phases 3, and phases 1, for just conductors between 1 and 2, but you also have for others from 1 and for 2 and 3, etc. This was sag-tension report. Now I will create support report. Of course, just select your power line, and you can print for all the supports. And now I will save this as Excel workbook and open that immediately. Okay. Save like support report, and now I will get my report in Excel window, so you can see conductors and ground wires with their models, temperatures, and wind pressures. Then you have three tables. It is a table of conductor loads on attachment points with orientation, with name, and forces. Then you have your insulator loads on attachment points with name and with weights, and of course you have your orientation, it's back or front. And the last one is are loads on support with their forces. And the last one is power line coordinates report. As I said, for that you can choose your print for all and your precision, for example, this precision, and just click OK. You can save that coordinates. Save that, and you can see all your supports in your power line, the coordinates, and what type is it. You have T as a tension and S as suspension support. Now I explain that, and of course before I finished, I want to say that if you want to know what kind of formulas you used in our software, you can always go here on this icon. It's called help documentation, and you can see all formulas we used in our software. Now my colleague Federico will continue. He will explain you how to generate your beam models of power line. Thank you.
Thank you, Stevan. Hello, everybody, once again. I came back, and now I will explain you more about IFC. First, I will show to you how to use IFC import. You just need to select IFC file. In this example, my IFC file represents a bridge, and I will open it and wait a few seconds. And now you can see that our IFC file is imported. Now I'm going to show you how to do IFC export and how to actually create beam models. Here we can choose which power line to export. In this case, we have only one, and here we can choose which surface to export. In this case, we also have only one. Here we can choose IFC certification. We will stay for this. And of course, I will check this open IFC file, and I'm going to click on OK and just give some name and click Save. And now we just need to wait that our BIM model is created. It will take a while. We use a free BIM Vision software, and we just wait to create it. This is actually only software in the market for now, which have support for BIM. And now I'm just going to zoom it a little. And here we can see support insulators and catenaries. It's actually conductors and ground wires. And now I'm just going to click on support. And here we have metadata about selected support. The same thing is for insulator. This is metadata for insulator, and finally for conductor. And here in this upper section, we have IFC structure including conductors, supports, and of course insulators. And that's all for me for now. And thank you for attention. And now my colleague Peter will continue. Thank you once again.
Okay, thank you, Eriko. Thank you, Stefan. I will go back to share my screen. Okay, actually, we present you the main features of the PowerPad. I hope it was really useful for you to meet this new solution and to meet these new commands in our solution for creating power lines. Maybe until you wait your questions, I want to share with you one more slide, like one highlight of our presentation. And that is that PowerPad is, we believe, and when you compare with other solutions on the market, PowerPad is tailored for advanced overhead power line projects. What it means with PowerPad, you can to create 2D projects of the power lines, and also to get calculations on which are actually loads or actions on your power lines. Like we mentioned it before, PowerPad provides 3D model generation. It means you can record in IFC format. Of course, when you have record of the power lines in IFC format, you can use it or applicate in any of the visualization. What is also important, like I mentioned, with this approach, we want to advance actually or to get better advance of the power line projects, because your project can be digital twins of the power lines. You can use it, put it, and take on the side actually virtual digital model of the power lines. It's the time to finish this webinar. At the end, I want to say thank you for your attention. If you have any questions, please feel free to contact us on our email, phone, or to visit our webpage. Of course, if you want to be in touch to the social channels, we are available through LinkedIn and YouTube. Thanks one more for your attention. Stay safe and have a nice rest of the day. Bye.